Okay, so we've got a differential equation here. Y prime of x equals 1 plus x y of x squared, where x is our independent variable and y depends on x. I've got an initial condition here, y of 0 equals c, and x is greater than or equal to 0. Okay, now how are we going to go about solving this? Well, for this video we're going to look at something called Picards iteration. So that involves integrating several times for each iteration. So first of all, before we start that, we need to do some setup values and what we're going to integrate to get our iteration sequence working. So y of 0 equals c, so therefore we can say our y0 of 0, that equals also c. Now we need to set up our function, our f, in terms of x and y. That will equal 1 plus xy squared. That's our setup so far for our sequences. So we've got c and we've got 1 plus xy squared. Okay, now what we can do is now we set up our sequence. So we've got y of n plus 1, so that will be the next one in the sequence. Here we've got y of 0, so that's our first term. And then we have that equal to c, which is our first term here, because if we plug in 0 into here where we've got x, this will give us our value for c. Okay, now here we've got x times y of x squared. So here we know x does not equal 0, so the x is not going to disappear. So we'll have to keep the x into that one there, and then we're going to have to keep integrating our y function. So here we add on the integral from 0 to x. So as we've plugged in 0 to x in our parameters of integration, we need a dummy variable. So now we've got our d of t. So t is our dummy variable to represent our x. So we're going to need a t for our integral. And then y of x, that will now become y of t. But as it's an iteration, we need our yn of t. So that's our previous iteration. And as our function is y of x squared, we also need to square this term. So that's our setup for Picards iteration. Okay, so now what do we do with this? Well, first of all, we need to calculate what our variables will be for our first one there. So that one there is c. So y of 0 equals c. So here we plug in as c. So let's go for that. So y of n plus 1 equals c plus x. These will always stay like this as part of our answer. And then 0 to x t times yn of t. So n is 0. Here we're looking for the first one. So now we've got c squared. T times c squared dt. Okay, so here we're looking for y of 1. So here y of 0, n is 0, plus 1, so that's y of 1. So we can put that as y of 1. So now what we're going to do is integrate this with regards to t. That's looking pretty straightforward. So c plus x plus integral of t with regards to t is t squared over 2 times c squared. And then we calculate that from 0 to x. Okay, so let's just solve that a little bit more. So c plus x plus, okay, where we see a t, we put in an x. So now we've got x squared c squared over 2. And then subtract when t is 0, the whole thing will disappear. So now we've got y of 1 of x. Basically, that's our first iterative sequence trying to find our solution. So let's put that in here. So y of 1 equals c plus x squared c squared over 2. Okay, now let's try and find y of 2. So now it's for that we'll need to plug in here our yn of t, this function here, this value here. Okay, so let's take this off the board and let's try that out. Okay, so let's set up our integral. So y of n plus 1 will equal So now we've got y of 1. So what we're switching for here is y of 2. And then we've got c plus x. That's always going to remain in our formula. And then we add on the integral from 0 to x t times. Now we set this out in terms of t. So c is our value, but x is our variable. So we need to write this in terms of t. So now we've got c plus t squared c squared over 2. And this is all squared. So as we're finding y of 2, this one here will be our y of 1. So that's what we're plugging in there, and then integral with respect to t. Okay, now before we can integrate, we're going to have to expand this out and then integrate from there. So let's do that. So c plus t squared c squared over 2 times c plus t squared c squared over 2. Okay, so a lot of foiling out to do here. So let's try that. C will distribute with everything here. So now we'll have c squared plus ct plus t squared c cubed over 2. So that's the c taken care of. Now let's do the t. Let's distribute the t. So now it's all positive, so we'll keep these all added on. So we'll add on ct. So let's write that as ct plus t squared plus t cubed c squared over 2. And then now let's distribute this one. So now we've got, add that on again. So now we've got t squared c cubed over 2 plus t cubed c squared over 2 plus t to the 4 c to the 4 over 4. So that'd be that one times that one. So that's what we've got so far. Now let's see if we can do some simplification on this. So c squared is the only term left on its own, so that's the c squared. What about ct? We've got a ct here and a ct here. So that's now going to give us plus 2ct. So that's that and that taken care of. What about now t squared? So we've got a t squared there, a t squared there with a c cubed, and a t squared there with a c cubed. So let's just leave the t squared on its own for now. So that'll take care of that. And let's see if we can link these two together. T squared c cubed over 2 plus t squared c cubed over 2. That will just give me t squared c cubed. So that will take care of that one and that one. Now we've got here t cubed c squared over 2, t cubed c squared over 2. Again, as before, that will give me t cubed c squared. And then the last one here, that's only this one left. That's going to give me t to the 4, c to the 4 over 4. Okay, so that's all of those. So now what I now need to do is now multiply these all by t. So let's clear this up a little bit and let's start to multiply this up on the next line. Okay, so now that's my calculation on the previous one. And multiply all these by t. So let's just do that now. Let's just distribute this t. So now we've got t c squared plus 2c t squared plus t cubed plus t cubed c cubed plus t to the 4 c squared plus t to the 5 c to the 4 over 4. Okay, so now I've got two terms here with t cubed, so I could just write those as t cubed 1 plus c cubed. So that's how I'm going to write that one. So let's put this now into my integral and let's integrate. And as these are all with respect to t, it's just going to be a simple power rule calculation for my integral. So y of 2 will equal c plus x plus, let's make room for my integral, and now tc squared plus 2c t squared. Now this one we said we was going to break apart into factors, so take out the c cubed, so it's 1 plus c cubed, and then t cubed, so that's all my t cubes. Now my t to the 4, I've got t to the 4 c squared plus t to the 5 c to the 4 over 4, and that's integrated with respect to t. Okay, let's take this off the board here, as now I've got my integral in place. Okay, now we're ready to integrate. So that equals c plus x plus, now just to be clear, when we integrate and we calculate it over the parameter from 0 to x, all of these terms will disappear at 0. So the answer to my integral, I can just plug in an x for my t when I've integrated. So I'm going to go straight into that rather than mess around trying to subtract all these multiplied by 0, which will just disappear. So I'm going to go straight into integrating each term and then substituting my x, because that's what will give me my parameters of integration. Okay, so t times c squared, so that's going to give me c squared, t squared over 2. But my t will be an x. So that's how I'm going to do all my calculations on here. So now I've got here plus 2c t squared. So now I've got plus 2c x cubed over 3. Then the next one here, I'm going to have t to the 4. So plus 1 plus c cubed, t to the 4, and that will all be over 4. My t will be an x. So just so as we can see that happening. Next one here, straightforward, I've got a t to the 4, so there'll be x to the 5 over 5. And c squared. And then here, that will be t to the 6 over 6. So that become x to the 6 over 24. And then c to the 4. Okay, so that's my second term in the series. Now if you want to, we could go on again and we would square this value here and then multiply that by the t when we get this all in respect to t. But I'm going to leave that to you guys if you want to take care of that. But basically my series so far for my second iteration is this one. So that's my second iteration using Picards theorem. So I'm going to call that y of 2. So that's y2, make a space in there to write that. y2 of x. And my y1 of x is this one here. So that's my first iteration using Picards theorem. And eventually we'll get like a Taylor series all the way along, and we'll get us closer and closer to the value of our y of x. Okay.